The peculiarity of quantum immortality is that it excludes the probability of consciousness entering the world with lethal outcome, because death in such a case serves as a barrier, which excludes this probability. Quantum immortality sounds very not modest, I would say impressive, and as it seems to be a logical argument in favor of immortality, but is it logical enough to carry such an impressive name? It took me a long time to understand the mechanism of quantum immortality, and it seemed to me that nobody understands it, since nobody explains the very process of transition of consciousness to the world favorable for us, taking into account equal probability to get into any of them. I searched for an answer to this question for a long time, and finally found it. Having calmed down, but at the same time anticipating a certain catch, I decided to watch one video in scientific subjects, which was not connected with quantum immortality. Having watched it, I decided to go to bed at last. Well, as is often the case, I'd like to start by remembering, and for some people perhaps even learning, how quantum immortality works. We need this so that we have the same understanding of what's going on. It is generally accepted that there are two leading interpretations, the Copenhagen interpretation and the many worlds interpretation. Today we'll only touch on the many worlds interpretation, or rather what Anna gave rise to quantum immortality. From the many worlds interpretation, quantum immortality takes its foundation, and that is the ability of probability to bifurcate worlds that if, at any probability there appear additional worlds with different outcome. It is not strange that at probability of death there appear also two outcomes, life and death. And if we combine this with the fact that probability appears literally always, we get a wide palette of outcomes, including consciousness, which acquires immortality. And to add an epic prefix to it, there is one nuance missing. Let's analyze it in the experience. We'll need it in the future. I won't surprise you here, it's a classic. Let's imagine a test subject with a gun pointed at his head. And the gun has a randomizer that fires with a 50/50th chance. With each click, there's a probability which is accompanied by a split universe, with different outcomes. But from the subject's point of view, he always stays alive because he can't observe what happens after death.
Yeah, boy.
At this point, there may be a misunderstanding like mine. For this purpose, let's make an analogy. In my understanding, quantum immortality is a graph, but I think it will be more convenient to explain with a balloon. This blue channel represents the stream through which consciousness can move, roughly speaking the world or being of the subject. And this is the subject's self-consciousness. It exists in the present, which on the right is the future and on the left is the past. And this improvised stopper is death. When death comes, it stops the consciousness in time or leaves it in the past or kills it. It's all intuitive. We've got the basics down. Now let's see what the different processes look like in this analogy. This is what probability looks like in the Copenhagen interpretation, and this is what it looks like in the multi-world interpretation. Since in the many worlds interpretation probability has the property of splitting worlds, this is what death looks like in the Copenhagen interpretation. Again, no surprise. And this is what death would look like in the many worlds interpretation if quantum immortality existed. And yes, death in the many worlds interpretation does not imply quantum immortality. Toward the end of the video, you'll see how death in the many worlds interpretation works. The peculiarity of quantum immortality is that it excludes the probability of consciousness entering the world with a lethal outcome, because death in this case serves as a barrier that excludes this probability. And so we have understood the mechanics and peculiarities of quantum immortality. Now let's return to our subject. If we take into account all of the above, it turns out that our subject will never die in his conscious temporal chain. He'll have a car accident, lose a limb, but stay alive. He'll get lung cancer from prolonged smoking, but he'll stay alive. In his old age he will have Alzheimer's, then dementia, but he will stay alive. Every next generation after him will die, but he will remain alive. In the course of his life, if he can be called that, he will lose all his senses for various reasons, but he will remain alive. In the end, all that will be left of him is consciousness in its absolute sense, which will exist forever. Absolutely everything will disappear, but he will remain alive. This is quantum immortality. But don't be sad, we're all going to die. But before that, let's go back to the test subject. What if I told you that this experiment doesn't reflect reality? There's an unacceptable margin of error, and it's not the size of the subject's head relative to his body. By the way, this analogy has the same bias because it describes the process of the previous experiment. To eliminate this error, we need to do a little calculation. No, close the window. We need to introduce some details into our experiment that won't change the outcome of the experiment. But will make it possible to make a small calculation. A subject with average anthropometry has a gun pointed at him at a distance of 1 meter from his head. The gun is a Glock 17 with 9 IMMORTALITY parabellum cartridges. The randomizer gives the result instantly. In the experiment, for simplicity, death occurs as soon as the bullet reaches the center of the brain. With all this data, we can calculate the time from the moment the randomizer is triggered to the moment of death, which is, that many seconds. That probably doesn't tell most people anything. But let's go back to the experiment. This is an experiment that we've done before, and thousands before us have done this particular experiment. And this is an experiment that more accurately represents reality. Now let's compare these two experiments. To see the differences, you have to slow down a little bit and look at the experience in detail. The error of the first experiment is that, in the first one, we neglect the time between probability and death, thereby unwittingly adjusting the experience to the peculiarities of quantum immortality, for a better understanding. Let's complement these experiments with the ball analogy. This is how the analogy of the erroneous experiment looks like, and this is how the analogy of the correct experiment looks like. This is the moment of probability, and this is the moment of death. There's a fraction of a second between them. In this case, death is not a barrier, which eliminates the probability of death. This analogy can be applied not only to this experience, but to absolutely any death, from death by flu to decapitation. Because every death is a consequence, and every consequence has a cause, and every cause needs time to generate a consequence. No matter how small it is, its presence is enough.